In this lesson, we will see two, maybe a bit more complicated examples of while statement. This is the first of them. We want to have a script that will start working when another script finishes its execution. Of course, it would be good to have a kind of communication between the two scripts. One of such very simple communication protocol may be agreement that when the first script finishes its work, it should at the end create a file with a well-defined name. This would be a signal for the other script to continue its execution. That's something what we want to implement here. The script will be named finish job. First, we need to know the name of the file that should condition real start of the second script. Here I will name it tmp go.txt. Our script will execute while loop so long as the file does not exist. The other script will perform its own activities, and our script will be checking from time to time if the file is present. If not, it will do it again and again. Finally, when the other job finishes, our script will find out that the file exists and will stop looping and waiting. It will be possible to continue some work. How should we build the condition in the while that should be executed so long as the file does not exist? That could be exclamation mark, so negation, of the condition -f $file, so the file exists and is a normal file. While the file is not existing, continue to iterate in this loop. Generally, the waiting part of the script could be considered as ready, but we will make it a bit more efficient in a moment. In the meantime, when the waiting finished, the script will execute next commands. Our command will be again simple. We will just display information that the file exists so we can continue. Most probably, in the production script, something more intelligent would happen here. Files will be compressed, copied, removed, users will be alerted, generally whatever, but we want to keep this example simple. So let's come back to the loop instructions. The currently presented here while loop would quite hard impact processor time. This kind of waiting is very active. We ask if the file exists, and because it doesn't, we ask again and again. It would be better to have short breaks between each question. To optimize the loop, we will first display a dot on the screen so that we can see the progress, and moreover, we will not jump into the next line after that. That's how the -n option works for echo. The second action is the glue of the optimization. The script will go sleep for a second. To test the script, I can run it and it should wait for the file. In the meantime, I can establish a new connection to the server. In this second connection, I will create the file expected by the running script. When the file is created, the while evaluated the conditional expression and it found that the file exists, so the loop was not executed the next time. As a result, the next commands from the script were executed. Wow! We have created a way of communication between scripts. Quite handy solution that needs to use the while statement. Similar problems can be also solved in another way. Look! The new version of the script will be similar to the first solution, so I will start with copy of a script. This time, I will make a potential programmatical error, a never-ending loop. While true. Some programmers could write here 1 = 1, but the meaning is the same. Execute forever. Of course, my goal is not to hang with the script. Under some conditions, I wish to break this loop. So what will be done in the loop? I will display the dot, I will sleep 1 second, and I will check if the file exists. If there is no such file, I will go to the loop condition, and because the condition is always true, I will display the dot, I will sleep 1 second, and I will check file existence. However, if the file existed, I will issue break command. The command breaks the loop. Next instruction that is executed just after break is the first instruction after the loop. The condition of the while statement will not be checked. Break is powerful. It breaks the loop without any exceptions. Let's see that in action. Here, there is our script that prints dots and checks if the file exists. Each time, it sleeps 1 second, so the CPU is not overloaded. At some point in time, the file was created by another process. Our script checked if the file exists. As it was there, the break was executed and the loop finished. As a result, the commands just after the loop were executed. That's all. So we have demonstrated how to communicate two processes with each other using simple idea of checking file presence. Now let's come to another example. Let's imagine we are working with an application that creates invoices and saves them in files. The application requires that for every day of the year there should be a different folder where the files will be saved. So at the beginning of the year, we are supposed to create a directory for the year. In this directory, create subdirectories for every month, and in each month's directory, create a separate subdirectory for a day. We can simplify this scenario and assume that each month has 31 days, even February. The script will begin with definition of few variables. Year 2030, number of months 12, and number of days 31. The base directory, where all the subdirectories should be created, is tmp. The variable m will store the value of the currently processed month. The first loop will process all the months. The condition defining how long we want to create directories for the months could be like $m less or equal $months. M starts with 1, and every time in the loop it will be increased. When m is 13, the script should end. What should happen in the loop? We need to iterate over days of the month. The variable for days could be named d. Initially, the value of d is 1, so we start with the first day in the month. Now it's time to create the while statement. How long will we create directories for days? So long as the $d is less or equal days. In the internal loop, we can first build the variable with the name of the subdirectory that should be created. The parts of the name include base dir, / the year, / number of the month, so the variable m, and finally the number of the day. To be able to see how the script progresses, we can print the directory name. The next instruction can be create the directory. This will be done with mkdir-p. What's the meaning of the switch p? Normally, when we create a subdirectory of a directory, this parent directory needs to exist. When running mkdir with the p switch, if the parent directory does not exist, it will be created. So when, for example, we will create the first directory for the 1st January 2030, the command with option p will in one shot create folder for the year, month and day. A very important point in the loop is the incrementation of the d. This allows to go over the days of the month and to stop the loop when the value exceeds 31. Let's analyze how the loop will work. At the beginning, month will be 1. The day will also be 1. Next, in the internal loop, we will create subdirectories for every day of the month. In each such loop, we will increase the value of d. Every time the value will be tested. When finally the value will cross the value 31, the internal loop will end. The next instruction will change the month number to 2. As this value is still lower or equal to 12, the external loop will be executed again. So the history repeats. The day number will be changed to 1, and now the internal loop comes into play, and we will iterate over 31 days of February. Ha! Should this irritate you, you can calculate on the fly the limit value days, so that for each month we will have the exact number of days as that should be. The loops will spin around until finally the month value will be increased to 13. This will make the condition of the external loop false and the loop will end. Now we are ready to test the script. My screen is now full of dates or directories, but it would be better to check directories on disk. Here we have year 2030. Now we have subdirectories for months. And here are the days of March. It seems that all the work was done in just a second. Can you imagine how much time it would take to do it manually? It's good to be able to script. So, you are invited to the next lesson where we will learn about arrays.